Okay, so we're back, hopefully. Before we go to that the thing we were doing, just like a small recap so everybody's on the same ground. Somebody suggested to me that if you are new to Scala, maybe it will be a better idea not to type that things into the text editor, but just follow what I'm doing. And I'll commit all the changes into separate branch at some point, maybe during the next break, because I didn't have a chance to do it right now. So you will be able later on just to go with the exercise. People who are familiar with Scala, it will be better if you could just follow with me. People who are not, maybe it's just better to see what I'm doing. And as a recap, why do we need type classes? Like, it seems like an extra effort. The reason for that, there are basically two reasons. Being more abstract and have a little bit more safety within our program. When I say being more abstract, in that show example, previously we had a method that was saying hello only to a user, which is usable as long as we're only using it with users. If making it a little bit more abstract, saying I will take anything like A, whatever A, we're making our code more generic, more abstract, but now the boundary expands, number of cases that we can use it expands. And we'll see later in this presentation that also it limits the possibilities of the implementations, which is also a nice feature. And the other stuff is, like with the toString implementation, or equals implementation that you guys were doing. Think about equals, right? Okay, so how many of you guys actually did a little bit of JavaScript in your life? Yeah, string equals integer, right? How cool is that? And in Java world, we fixed this, right? Every equals implementation has a contract. So if I'm actually comparing a string with integer, I should always get a false. It's within the contract of the equals method. But since I'm always going to get false, and most probably comparing two things which are different, like comparing integer and string, doesn't make any sense. So if we have a type class like equals, which you guys just implemented before the lunch, you can use it instead of two equal signs, and it's what Scala Z is giving you. It gives you like a three equal signs, which is basically our equals type class. And this gives you additional bit of safety, because right now, if you try to compare two things which are different, we try to compare user with string, which you might. With normal equal signs in Scala, compiler will be happy. Like he will always tell you false. But like if it's false, then instead of comparing it, you could just put the value false, and that would be exactly the same thing. But now if we have a type class equals, and we know it always only compare two things of the same type A, whatever that A is, we get additional set of safety. So hopefully this helps as a recap. Now, with all the Scala craziness, I understand for people who are new, this is all weird. So if it all looks like a old Egyptian's alphabet for you at this point, just think of this. Like we define our type class by saying like trait, the name of a type class, and the method that we want to have. And then we have some addition like machinery, which is always exactly the same for every type class. This apply method, the ops class, and all that, which then allows us to do basically this. This is what we get. If I say any A is a member of type class, this is what you really should be looking at this point if Scala is too crazy for you. If I have some A, whatever A, and it's a member of type class show, I will get a method show for free. And let's like, if all that other stuff was crazy, just stick with this part. All right, so we had a problem. How to implement this, right? Can we implement it right now? Not really. We don't know much about F. We know F cannot be string. It has to be something which is polymorphic by itself, by nature. But we don't like it can be an option or maybe an either type. But we don't know anything else about F. Right now, our method is too abstract. We had a concrete implementation just a moment ago with task or option that was very concrete. But now we just went too far away. We are too abstract. We have absolutely no idea what an F is. But if we go to Scala Z, and we will find a type class which is called functor. And functor there we go. Functor comes with one method map. And that method map is saying, if I have something of type fa, so if I have value a closed over some f, and I have method that will go from a to b, then for free, I will get f of b. And this is basically what we need. So I could say f is a functor. Right? This is what I'm saying. F is a functor. So now I can create an instance, I can get an instance of functor for f. I can call map on it. Map take as a first element some value a closed over f. In our example, that is string, so it will take that string. As a second argument, it takes a function that will go from a to b. In our example, that's length. It goes from string to integer. So we will say length. And now this compiles. So just let's stop for a minute here, because that's the simplest type class that we can get. This is the definition of functor. Somebody might ask me right now, okay, but how is it implemented? I don't know, and I don't care. I really don't care. I'm just saying, in my implementation, I'm saying, listen, you can call my method with any type that you want. I don't care. I'm restricting you. I put like one single condition. Provide me an instance of functor. So you need to have somewhere object that extends functor for your type f. So if I call this method length operation with, let's say, with option, right? Then f is going to be my option. Then I need to have functor instance for an option. Okay? Does it make sense? Yes.
So in the type signature, we say f of underscore is a functor. You're just talking about f itself. But every single time it does have to have its own generic or something. It couldn't just be string as a functor. It has to
No. No, because look at the definition of functor. Functor is for type constructor. It's for something that constructs your type, like option, right? Option itself is not a type. Option of string is a type. Option of int is a type. And here saying functor is only for higher kind of types. It's for f, which will eventually give you a type, like for example, f of string, f of int, and of whatever. So now if I and Scala Z, they also underneath, like if you look at the implementation, they already have all those ops classes and all that. So I could also say basically, instead of saying this, I could say string map length. But it's doing the same thing that we were building before, right? This ability to call that map function. It just by saying f is a functor, we magically get that one more method map. We still don't know what f is, right? The only thing that we know is it will get that map method. And how that method will work, well, I don't know, right? And I don't care at this point. Like, you will be calling my method, you will be calling length operation with some type, and now you're responsible to providing me that type class. Okay? So now I can say, just to give you an example, so I could have a val string, right, which would be like hello. I could have val maybe string, which would be, well, option of that string, so some. I could have string error, which would be of a type, let's say, throwable and string. So it can be something like string write. So write is just a method from Scala that constructs you the either type. Or I could have fetch string. So fetch string. So it's a task of string, like string here. And now, and now I could say length operation, and I could call this with string. I could call this with maybe string. I could call this with string error. And I could call this with fetch string. Like most of the time, for some types the Scala compiler will be able to infer types. For some it will not. I would just put those types explicitly. So what kind of type I would like? Maybe string is. I would just maybe say here. This is option, right? This is option of string, right? So what will be what I should put here? Option. Option of string or just option? Just option, because I'm providing the type constructor. I'm just saying this f will have a hole, and option has a hole, and it will construct you the final type. So I will have the same thing for task. Like fetch string is just taking so so everything is clear. I'm calling this method with some f, right? So if I'm calling this method with task, then obviously that type has to be task, right? Now the question might be, what about the either type? As you remember that we were showing this when I was showing you the intro to Scala. Either type has two types within it, like A and B. So we have to partially apply one of the types, and this is where you will use that kind projector. So you can do two things. You can either say type error A. So you're creating a new type, and you're saying it's either throwable or that A. And then you could say error. Right? You could do this, or you could also do the same thing like inline, where you just create a new type with a kind protector. So I would say it's throwable, and I'm putting here the hole, and it all hopefully will compile. So far, let's see, compiles. Now the question is, can I still use my function? My function is I want to use it just with string, right? I don't have string closed over anything. It's just string. Where there's this nice little trick, which is within the Scala Z library, and they call it ID. Then the way the ID looks like is basically something like this. They say IDA is just A. So you could say ID here, and it would work. If it's weird, don't worry about it. It's not really that important. But you could still call your function with whatever type that you basically want. Are we good? Does it make sense? So what did we get? We get our ability to call right now our function with all the types that our users, before they were just creating all those tasks and we had to re-implement our function. And now we just give them the method and we're saying, pick your type, your call. I don't care. Just give me an instance of functor and we're good. And Scala Z will give you. So why does this code compiles and works? Because for all of these types, option, partially apply either type, task, Scala Z gives you already an instance of functor. If I have my new crazy type, then I had to provide a functor for it explicitly. But here for all those types we get the functor instances for free. Are we good? So far.
So when you say for free, it's because you're importing one of these Scala.
Oh yeah. It's when I say for free, it isn't really for free. I'm just importing them. It's basically those two imports. The last one is to provide. The last one, this one, is to provide task. So here is task basically. Okay. So now. So that's one thing, right? So that was okay. What I will do is I will leave that main method. Normally I would just delete it, but the thing is, people ask me to actually push that code base at some point to repository, so I will leave it as it is. So now let's now make this problem a little bit more complicated. So let's say we have a method class, and the method class takes two integers, right? One integer and a second integer, and gives you an integer back. Can you imagine what the implementation is going to be like? Crazy, right? And so now let's make right now a plus operation. And it's going to be one more time parameterized by some f. We can say already it's a functor, right? We don't really have to, right? We can, for a minute, we just say it's any f. We're going to have f1 of type fint. we're going to have f2 of type f of int, and we would like to return f of int. Okay? So now the question is, can we actually do it? Well, obviously we don't know anything about f, so let's just say f is a functor for a minute, right? If f is just a functor, can we, it's not compiling because
you're missing underscore behind the concurrent.
which one? Oh yeah, thank you. Thank you very much. And now it just needs to find a method to run. Okay, so we're good. So I'll just give him a main method here, empty right now for now, and yeah. So now, can we actually implement this? Can we take advantage of the fact that we have a functor? We have right now. So functor had a method map that takes one argument and applies it to your value, which is closed over f. But we have something different here. Now we have a function that takes two arguments, right? We have those two arguments. We have f1 and f2. And what we really want to do is we just want to say, no, we want to apply f1 and f2, but we don't really can do that because f1 and 2 are not integers. Those integers are closed over some f. So the question is, can we take advantage of functor and try to apply those two arguments, even though the functor is just taking one argument in method map? And the answer is no, we can't. Well, we could try. We could say something like this. We could say temp, and we would say, so we could say f1 map, and now method map can takes a function with one argument, but plus is a function that takes two arguments. But we learned about this little trick, which is called carrying. So we can say plus carried, right? So this will work, right? The compiler is still happy, still compiles. But the thing is, we just only applied one single argument. So the type of temp is really f of int to int. So we just applied the first argument from f1. But what about f2? We're screwed. We cannot really do anything about it. The only thing that we can do is learn about another type class. And if we go to Scala Z sources, Scala Z, there's a type class called apply. And apply is check this out. Apply is already a functor. So if you're saying your f needs to have an instance of apply, you get for free methods from apply, but you also get method map because apply is also a functor. And apply comes with little method ap, well, apply, which check this out, takes some value of type a closed over a. It takes a function from a to b closed over f, and it's just giving us an f of b. This is pretty much what we need, right? Because we can now say we have okay, so first of all we need this. We need some value closed over fa. Well, that's our f2, right? And then we also need so we will say two things right now. We will say f is apply. We need to have an instance of apply, and now we can say apply. We just take the instance of that type class. We call ap on it. And what AP needs? Well, the first argument needs to be our value that we're going to apply to the function. Because what AP is doing is it just allows you to apply this argument to this function, and both argument and function are closed over f. That's all it's doing. Allows you to apply an argument closed over argument a closed over f to a function a to b closed over f. It allows you to call this function with that argument. And this is basically what we want to do. So we will say f2 and temp. And it compiles. Since it compiles, let's see it actually works. So I have I1, it will be 10. I2, let's say it's 20. So now I want to call plus operation. I will say, let's say we call it with an option, right? So now we call sum I2 sum, and so just so we're sure it actually works, we will get, should compile, hopefully, and it compiles, and the result is over here. So sum 30. We got our value back closed over some f. Any questions? We're gonna take those static type classes slowly because like this is probably the reasons why you guys here. So I'm just gonna be 100% sure everybody understands what's going on. Yeah.
Does apply has its own syntax like the map? Is that?
Yes, I'm going to show that in a minute. Yes, it has. If you think that like whenever I was actually pre-running those, I didn't pre-run the whole workshop, but I was pre-running those examples in 2 meetups, and there was always one person who was 100% sure he could actually implement this with just a functor. So if you're one of those guys, do it. I dare you. I'll buy you beer. I will buy you whiskey. You need apply to implement plus operation, because functor will only work with the functions which are one argument function. Apply gives you this ability to apply argument to a function, and both argument and function are closed over f. Yes, Scala Z comes with an operator, like but instead of having, so what you would expect most probably would be something like f2 ap temp, right? This is what we expect, right? It's not that easy. So it's basically f2, this operator, temp. And the reason for that is basically they just use operator, not name AP, and it just basically try to be as close to Haskell probably as they can, because apply in Haskell is just only an operator. Remember, they don't have classes, like they don't have those problems that we're having. They just basically have structures and functions, or operators. That's why they created an operator. But this operator is basically doing the same thing. But let's look back for a minute at this implementation that we had. If we go to Scala Z sources one more time, and we will go see apply one more time, we will see there is a method. Yeah, it's a little bit of craziness. Yeah. This method over here. Yeah, Scala is full of that. Those, like, for example, as you remember, function is just an object, right? And function 0 is an object. Function that doesn't take arguments has a class function 0. Function which takes one argument has a class function y. And we have like function 1, function 2, function 3, function 22. So they did the same thing. But basically, check this out. There is a method apply to, which is doing exactly what we were doing just a moment ago. So it's calling carried on our function, then it's mapping over it, and then it's calling AP on those values. So basically, what we just did here, before we could just say apply for f and apply to, and what apply to is taking as first it takes those two arguments. So it's saying argument, first argument, second argument, and please apply this argument to this function. So it's just a convenient function that you can use, but it's doing exactly the same thing. Okay, it's just no magic here. It's just like a little bit of syntax sugar that they added to the library. You might be thinking, okay, so now if let's say I actually have two additional arguments, right? Let's say this looks like this, right? And now I have f3 and f4. Does it mean I have to do like f3, f4, f5? Then I obviously have to change this, so this will compile, right? But then I also have to go here and say, oh God, how many arguments? 1, 2, 3, 4, 5, 5, apply 5. Yes, you have to do that. So in order to shield ourselves from this issue, and they come up in Scala that they came up with something which they call Applicative Builder, And Applicative Builder is nothing you would normally find in Haskell, for example. It's just a convenient or like a syntax that have a library to deal with application. And I would just show you. So it's a little bit crazy, and I say crazy. It's for a reason, because the argument for that operation looks like this, and they call it scream operator. All of this, this painting, and it looks like this. So basically, what it's if we were actually go to Scala Z sources, I mean, it's not really that necessary to understand, but if we go to Scala Z sources and we're going to look at Applicative Builder, we will see there's this operator which we just used. So it allows us to build build this object Applicative Builder, and it has the method apply, which is doing whatever we are doing. So if we had two arguments, it will just call apply 2, and then we call one more argument. So then when we actually run it, will call apply 3, and so it's just closing that craziness for us. The craziness continues in this file. So instead of having this in our code base, we could actually it's closed over the library. So now if my function calls looks like this, right? And if I happen to have one more argument, because for some reason there's a 3, I will just say, screen one more time for me, and let's say plus for whatever reason. So it's just a syntactic sugar, and this looks nicer. So for example, if you will find YouTube videos about Scala Z, majority of people start talking about Scala Z and functional programming, they start with an object called validation. And validation is this ability to accumulate errors. So you have a function that can return you a value, let's say a double, but there also might be an error, and you can accumulate those errors over validation. So apparently validation is applicative. So you will sometimes see they will use this operator, the scream operator, to actually, so let's say this actually is validation. So this could just, let's say it returns me a user, then it returns me another user, and that returns me a project. And then I could do something with a user and project, and if any of those will actually return me an error, I would have an error. But it's not really that important. I'm just saying it's a sugar that you will. I was thinking about skipping the scream operator, because it's nothing else as just calling apply 2, apply 3, apply 4, and so on and so forth for you. And I was thinking maybe skip it, because why put this additional set of complexity into this workshop, which is already pretty complex. But then I reckon you guys, maybe at this point, after attending this workshop, you will be looking at Scala Z sources, or maybe some other conferences talk or blog posts. I just reckon, be aware that if you see the scream operator is nothing else as just using apply type class underneath. So instead of doing this, instead of this line, I could just say apply for f, apply 3, then provide the 3 arguments, f2 and f3, and whatever the function that was supposed to be doing some stuff. So those two are equivalent. Okay? Okay, so we can actually keep the scream operator plus like that. I'm missing this, and now it should be fine. Okay, so, and it's still working. All right, so any question towards apply? Apply just gave us ability to apply an argument to a function in situation where both function and argument were closed over some f. Okay? What happens if I make this a little bit more complicated? So let's say, for example, f2 is not really closed over f. Actually, I have an integer, right? Like that. So this expect both of two guys, both f1 and whatever we will put here, to be f of integers, right? But we no longer have, the second argument isn't no longer f of int, it's now int. I need somehow make this int, this f2 here, lift it over f. That's what I need. Can I do it right now? Not really. Still, this code is very generic. I'm still working only with f's. With f, I don't care what it is. It's an option or either or task. I don't care. But it's right now too abstract for me, because I don't have this ability to take any integer, any value, and lift it to my f. Fortunately, there's a type class for that. And I'm going to be repeating this sentence all over again. So if I go to Scala Z resources, there's apparently a type class called applicative. Applicative sounds weird, but applicative is nothing else than just apply. So you guys remember, apply is a functor with additional method app, right? And applicative is an apply with one more method called point, or sometimes called pure. And the only thing that this method is doing is lifting our value of whatever type A into our f of A, which is what we need, right? Just a reminder, I still don't know how that method is implemented, because it differs from type to type. For option, it's going to be implemented probably with sum. With either type, it's going to be implemented with write. Right? With task, maybe with method now. I don't care at this point. The only thing I'm really interested when I'm implementing my function here is that I have ability to lift my integer to f of integer. So if I say applicative, I lost one person. I was prepared to list 5 at least at this time, so that's good. So if I call applicative, I can do two things. I can just say applicative f and called point with my f2, right? But this is kind of verbose. What I prefer to do is just say f2 point to f, and hopefully, okay. Oh yeah, so yeah, those guys, yeah, so actually I have to call my method with the integer, not with the option of integer, right? So now it compiles and it works. Yeah.
Are all the standard, or most of the standard types in Scala defined under applicative by Scala Z? Because I'm seeing that there's functor, apply, applicative.
Yeah.
So if I'm going to implement my own class as an applicative, I have more and more functions to implement?
Yes, basically, yes. Okay. That's how it's done in Scala Z.
So if I'm implementing something and I only need it to be a functor, I only need to worry
about it. If you have a type and you want it to be a functor, just say, I'm creating an instance for a functor, and that's it. But if you say it's applicative, now you have to implement 3 methods. You have to implement point, map, and basically AP, right? So those 3 methods have to implement. Now this point is a little bit crucial, because when I was learning first FP, applicative seems like this weird concept that I was struggling to actually understand. But I don't know how many of you guys just see that we're just basically following this pattern. This is just yet another type class that gives us a little bit more power. And this is important. When you will be working at some point with functional code base, and you will define your function and you will use the monad, right? And somebody will tell you monad is too powerful, because it only means, and we will see that in a minute, monad is just yet another type class. But with each of those type classes, we add power, a little bit of power to our type. Previously with functor we could just only map. Now we can do map and AP, and now we can also call point. So we are writing very, very abstract code, abstract methods, but sometimes we need a little bit more functionalities, and then we have to reach for more powerful type classes. And applicative is nothing else, it's just ability to lift your value into your F. So far so good? Awesome. So now let's go back. So let's say I have this is actually closed one more time over F. But it's not really closed over F. Right now F2 is going to be something different. It's going to be a function. Okay? So it's a function that takes a string and returns us that F. And let's say we will just call our plus operation with that string. So we're going to have something like called like seed. That's going to be our string. Can I make this a little bit? Do you still see it, or people at the back? All right. So I will just say, I'll just say there's some seed, initial integer. So here I can just say, let's say here I'll just call it with hello. And yes, if you're wondering, does that example make any sense, like from like sanity? No, it doesn't, right? I'm just need some simplest functions to talk about type classes and types, and you will still be able to do like real programming, business logic, and all that with functional programming. I just don't want to focus on that. I'm finding the easiest examples that we can find. So now, question is, so now f2 is not really f of int, it's a function that will give us eventually f of int that will take string, and now we have string seed. And now the question is, can we implement this? Can we?
There's a type class for that.
No. We don't need to. Exactly, we can right now call f2 with start string, right? This will hopefully work. Obviously it doesn't. Let's say why. Oh, because we need that function here. So here, let's say, so it's a function that will take string and will give us the. So let's say we will give us f of int. So let's say it's going to be length, and I will compose and then, and I will just close it over. So I'll just close it and say sum. Is this function is readable, or should I make it more or less Scala? Okay, so what I want to have is I want to have a function. So what I have a function is that function will take an integer, a string, right, and will return me an option of int, right? So I can just say sum as length. And it doesn't compile because of what?
Because the F2 is getting str passed into it instead of seed.
Seed, yeah, thank you. Okay, hopefully. And now it works, right? We get sum 50. So I should probably just, so you guys actually see the result.
But it could be just underscore length the sum, right?
No, because underscore. Yeah, it could. Okay, so far so good. We didn't need actually additional type class, so that's good. But what happens if I actually have my seed closed over f? Ooh, now it's spooky, right? Because this will not compile, and we actually need a type class for it. And a type class. So we will need somehow ability to put some, like, apply that seed, which is closed over f, to a function that not takes an f but just takes a string and will give us that f. So this is already crazy, but if we go to Scala Z sources, we will find a type class which is called bind. And bind, well, it just gives us what we want. All right? Yeah, hopefully you guys see it, right? This is the seed, and this is our f2. We just need to call it, right? So we can actually do it. So we can say, first of all, we need to say that we need a bind. So we add another, like we are still pretty abstract, but we add another power to our type f here. So we say that it has to be an instance of a bind for f. So now what we have to do is simply bind f, and there's a method bind, and it will take two things. First of all, it will take our seed, right? And secondly, it will take our function, which is f2. And hopefully, this will compile, but it doesn't. And the reason for that is I have to actually change my example. So right now, hello is closed over f. So in this example, it's just closed over option. Let's try it out. And yay, it works. But bind is special. Bind is special for a reason, because they have bind in Haskell, and obviously they had to think of a very weird operator for bind, right? And they did. So instead of saying seed bind f2, which you can also say, obviously they overrode this method, but you will also see they are actually using, what they're actually using is this operator. And if you've been doing functional programming for maybe a few weeks, you might have seen this operator before. Let's see if it works. It still works. Awesome. Any questions so far? Because I'm gonna do a little bit of weirdness and craziness in a moment. So are we good with bind?
Is bind, how does it relate to having a flat map?
You will see that. We will see that in a moment.
Okay.
We will see that just in a moment. I will answer that question in next few 30 seconds. Any more questions? So we still just needed a new functionality. Hey, bind actually has what we need, so we used it. Now there is another way how we could implement with bind the same functionality. We could start with saying, so I will keep this as a reference, or maybe you guys have it, so I'll just delete that. But so we could do something different. We could say we could just start with seed, and we could call bind on it. Okay. So now what bind needs here is a function that will take a string as an argument and return us an f of something. So let's say it's actually, so we will say it's a string s, and it will give us, well, f of something. So let's say it will give us right now, we can get f from f1. So we can just say f1. But on f1, this would compile. Obviously wouldn't work, but it would compile. But now we could just say bind of f1. So now what f1 is needing here, the bind, it needs a function that will go from integer to f of something. So I will say I have an a, which is an integer, right? And now you need that one more time, that f, because that's what the bind type signature asks us to have. I could say f2 will give me that f if I call it with s, right? So already this is giving me, crap, if I call this f2 with s, that will give me the value which is calculated by that function. And the last thing that I actually need to do is call map on it, and I will say plus a and b. It doesn't work for some reason. Not found value b. Oh, sorry, because it's a map. It had a map. So wherever was in b, and now it works. Now you might say the solution that we had before was nicer, right? And I would agree. But there's a pattern here. If so people who haven't worked with Scala and are not aware of what for comprehension is, for them it will not make any much sense, or do notation in Haskell. But for people who actually work with Scala, check this out. If I do a little bit of formatting here, so I would do something like this. I will say that, like that, and like this. And let me just format this for you a little bit. There's this pattern. Well, obviously I just said which pattern, which is for comprehension. But we sort of see like I get S from seed, I get A from F1, and I will get B from F2 if I call it with S. So let me just, so I will keep this implementation maybe here in comments. But the for comprehension would look like this. For comprehension would be something like this. I would say I get S from seed, I get A from F1, I get B from F2 calling that with S, and once I had all that, I will just yield plus A, B. Bind in Scala, for the reasons I I don't understand. There are some reasons. I think the way how language was developed at the beginning, bind is called flat map. And if you ever used Scala, you probably learned at some point that you can only use for comprehensions if you have a monad, right? Which was crazy. What happens was you can actually use, so this bind operator, there's also in Scala Z, there's also alias for it called flat map. So we could, instead of just calling this operator, I could just say flat map instead, okay? And Scala has this little syntax called for comprehension, which looks like this. When decompiled, so when desugared, we'll change this piece of code into this chained calls of between those values. So it gives us this ability. So this thing before over here was just a singular expression where we called functions within functions within functions. And this for comprehension is not one of those for loops. It's not a for loop. It's still an expression that will evaluate a value for us, but this gives us this ability, and underneath it will desugar pretty much to this. This is what Scala, well, Scala will desugar, but will say, instead of bind, it will say just flat map. Okay, this is what Scala will do underneath for us. So we have this nice ability to actually reason about our values closed over f with for comprehension. This is like a little bit of, some people say it's like adding imperative code in functional programming, because right now we have steps, right? When we look at our for comprehensions, those are basically steps. I retrieve the string from seed because it was closed over, my seed was closed over f, and I'm just saying, give me whatever is closed over that f. And then from f1, I'm just grabbing that value, right? Give me that integer, and this is going to be called a. And f2 was a function, so I'll just have to call f2 with my s argument, and now on the left-hand side, I will just get that value that was closed over that f. So this is nice little sugar within the language that gives us the ability to reason about our code base in more imperative way, like with steps of calculation. Some people look at it this way. Now, if you ever did Coursera a workshop, a class with Martin Odersky about Scala and functional programming in Scala, he told you that, well, for comprehensions only works with monads. But we don't see any monad here, right? So why the hell this code compiles and work? And I should actually show you that it works. Hopefully it does. It does. So why does it work? Well, the reason for that, let's see what this monad is, okay? Finally. And then we go to the bar and drink. Monad. Are you ready? You ready? Monad is just applicative and bind. That's it. We can go home. If you were here for a monad tutorial, that's basically it. You already know what monad is. Monad is a type class that combines two type classes together. It's a bind, but also it's applicative. Do you remember what applicatives gives us? Point, right? Ability to lift our value to whatever f is. And that's all. That's all we need. For the for comprehension, our example, we only needed bind because we were not lifting any values. We didn't have like an integer or whatever to lift it over to that f. We didn't need that. To actually write a for comprehension, you need, in Scala, you need a flat map and map. But if you have, yeah, pretty much, and if you have bind, you have all of those functions together. So there you go. Now you might wonder what's the point of this. Like, do I really need all that craziness to actually do what I'm supposed to be doing, and why they're paying me money as a software engineer? I mean, we understand. Okay, we understand. We get this with abstraction right now, with making a plus operation very abstract. We have this ability to call this method with option, with task, with all those little types, which is nice, right? But the question would be, is that the only advantage of making the code abstract? It isn't. There are a few cool other things that we could actually do. So let me call this main free. I will delete that. And now, okay. Question. I have a function. I have a method that takes an integer, and it will return an integer, and it will give me something. And let's think for a minute. We are only like, I know in Scala we can do all the craziness like throw exceptions and all the weird stuff, but let's for a minute think that Scala is pure functional language with all the weirdness from OOP. Okay? Can you guys tell me what this function is doing? If you don't know, I can actually give you a hint. Okay? Well, come on, I will buy you a beer if you know what it's doing. Anyone?
It's adding food.
Yes, that's what I also thought, but apparently it's doing, because it's, as it turns out, method is also a comment. Method of a name of a method is also a comment. You could call it sum. You could call it whatever you want. I don't care. It's subtracting an integer from integer. And compiler is happy, and so are your colleagues, but you cry. Now what would happen? What would happen if I say, oh crap, sorry. If I say oh, sorry. So if I say A here, and A here as well. Right now, I just make it very, very abstract method, just working with A's. How many implementations we can actually get here? 2. We can either return A1, right? We'll compile, obviously. I2, and that's it, right? So this is a little too much abstract, right? We got like the scope of our, because previously with integer, I could do anything. I could give you a constant value. I could subtract, multiply, do whatever I want, divide, right? Whatever things I could think of. I make this definition like very, very abstract. It gave me a very, very little scope of possible solutions, but that's not really what I need. What I need is a type class. And it's a type class, it's called, the name of the type class is called semigroup. Now, semigroup, that sounds like a proper math, right? We're going to look at this definition, it's going to be like 200 lines of code of weirdness. So actually, semigroup is a type class that just gives you one method, which is called append. Given the f and other f, I will give you an f. And this is one of those type classes that actually has a law. In this example, it's associativity. So if I'm adding f1, f2, and f3, it doesn't matter in which order I will add them together. So I can add f2 with f1 with f2, and then f3. Or I could add f2, f3, have a value, and then add it with f1. So the order of the evaluation doesn't matter. And it's one of the like laws actually makes sense. So for example, if you do calculations in Pawel, right? If you know that the operation is associative, there's no really you don't really care in the order of how things are going to be executed. So you can actually execute code in Pawel. So it's actually a pretty neat law. So when we say our type is a semigroup, right? Well, we could use this operator from semigroup. We could just say semigroup append, like, right? We could use append f1 and f2, but there's also a nice overloaded operator which looks like this. So I can just say and it should be right now called a1, right, and a2, which obviously makes sense because it's no longer an integer. So I could just say a1 plus a2. Now, two important things about it. there are still 3 ways to implement this method. I can return A1, I can return A2, or I can add 2 things together. But the scope changed dramatically. Out of infinity, I have 3. I will go with 3, comparing to infinity, right? That's one nice feature about it. The other thing to actually see in this example is, if you guys come from a craftsmanship movement, craftsmanship will really tell you that you should really name your variables. Like, I should know this is a user with the project something, right? And I know what I'm dealing with. And people who practice craftsmanship, they sometimes seek a functional code base, and they just like, what the hell? Because things are called F and A and G and H. It's not that we like to be like masochistic. It's not like functional programming is for people who like to like pain. It's not like that. It's just that most of the time our function will be so abstract that I don't know what I'm dealing with. I don't know if it's a user. Maybe it's a user. Maybe we're adding 2 users together. Maybe it's a project. I don't know. I give you a method for you to decide, and you just give me what I want. I'm telling you this has to be a semigroup. And that's it, okay? So it's not that I'm calling this A's because I like pain. It's at this point I only know I'm dealing with A's. I don't know what A is. That's why I will most probably call it A instead of user, right? Which makes sense, hopefully. Does it? Okay, maybe another example. Let's do something different. So. Because this is kind of important at this point. So let's say I have let it be sum as well. So let's say I have a sum which will take a list, and this will be a list of integers, right? And I want to return an integer. How many possible implementations I can have? Like here. Well, I could return 0, right? I could return probably any arbitrary integer I really want to return. I could just say, maybe I would just pattern match against the list. I would say that list is A, B, and a tail. Oh, sorry, like I just only add A and a tail, and I would just give you an A, right? So, or maybe I would just call fold on it, on the list. I would just say list fold, and that's basically, and then the fold takes like a 0 argument. So I would just say start with 0, right? I could do that. I could do all those things. Well, so let's try to actually implement it. I would just say list fold 0, right? Let's see if it compiles. It doesn't. Oh yeah, because it needs an operation, right? It needs to say plus. Happy? Not happy. No main. Okay, I will give you main. There you go. There you go. There you go. Happy? Happy. Okay, so now this works, right? But the scope of possible implementations is pretty huge. It's that all that I just put in those comments here.